Well, hey there, HVAC pros and enthusiasts. Are you ready to take your skills to the next level? The HVACR Learning Network has just launched an exciting new e-learning course, High Performance Heat Pumps. And guess what? We're giving you free access to the first 2 chapters. Whether you're in the field, training for that next step, or simply want to sharpen your expertise, this course is packed with everything you need to understand and master high-performance heat pump systems, especially inverter-driven cold climate heat pumps. And the best part? You can access it anytime, anywhere, right from your favorite mobile device. It's HVACR learning made flexible and convenient for you. So what are you waiting for? Click the link. Dive into the HVACR Learning Network and start your free trial today. Your journey to HVACR mastery begins here. Well, hello HVACR community. We're so grateful that you're joining us today. We're going to spend a little time talking about proper ways to detect leaks in systems. We spend a lot of time talking about our refrigerant transition. We spend a lot of time talking about how we're going to be moving into things like hydrocarbons and CO2 and HFO refrigerants and HCFC HFO blends. And so we really got to start thinking about what is the right way for leak detection, because many of us, when we came out of the field, we had learned on one technology, and that may not be the correct technology for us to be using in today's world of refrigerants. So we're going to spend some time with Nick Stojkovski. How are you, sir?
Good. How you doing?
I'm doing great. Nick is with INFICON, the leader in refrigerant leak detector manufacturing. I've used INFICON since back in the DTEC days, like when it was first introduced. And it was really a phenomenal piece of equipment, especially when we were working with commercial refrigerants, because it did a great job with all HFC refrigerants, which is primarily what I was working with at the time. But as we start moving forward, we got to focus on what detectors are doing what type of work. And so we're going to do a deep dive today. We're going to have an overview of quite a few products, but we're going to do some deep diving and we're going to do some hands-on demonstration of what refrigerant leak detectors are out there. So we're going to think back about the days of, when I first got into refrigeration, I was using a halide leak detector. So if there's anyone out there in the audience that remembers the old halides that were really looking for chlorinated refrigerants, we can't use those for looking for R290 leaks today, can we, Nick?
You can try. I wouldn't recommend it.
Most of those were using, propane torches to begin with. So, not a good scenario. So everyone, let us know in the chat where you're joining from. Every week, we love to see how large this community of HVACR professionals is growing. And let us know if you have any questions, any concerns, any comments along the way, so we can help answer these questions. And we'll give you some links to some other resources, and we'll even show you some training opportunities from INFICON as one of our training partners on the HVACR Learning Network. So, Nick, tell us a little bit about yourself and your involvement in the industry, and then maybe we'll dive into like the evolution of leak detection.
Yeah, absolutely. So just to introduce myself, my name is Nick Stojkovski. I'm the Global Applications Manager for INFICON Service Tools. So what I do is try and educate, also help develop some of these new products that we come out with, really try and get ingrained with our customers and try and listen to a lot of the technicians out there and some of the pain points they have, see what's changing, and try and help maybe change some of the ways that we do things internally in INFICON to try and come out with the best products we possibly can come out with, and try and make our techs' lives just a little bit easier. So, been in the industry for a little while now. Started at a local Daikin plant on the line, and now I'm dealing with leak detectors. So
Very cool.
you never really know where you're going to end up, and this has been a pretty fun journey. So INFICON's been a pretty awesome company.
We were talking about that just this last week. So I spent Monday, Tuesday, and Wednesday up at our office in Chicago with all of our team. And we were talking about like the evolution of the industry. And we're going to spend a little bit of time in the next few months doing some highlights of opportunities within our industry. Because you really said it. You never know where you're going to end up in this industry. And there's so many different places to be. It's important for us as educators, as we're preparing students for the field, just to help them understand that you're not just going to be stuck out there in installation or service for residential like commercial. We want you to go places. Laurie, thank you for joining us from South Africa. Glad to have you here. I haven't seen your name on here, so appreciate you being with us. And Osvaldo, thanks for joining us over in Belize, San Pedro. Bet it's nice there this time of the year. I think it's probably nice all year long there. So yeah, no, that's cool that you've seen the manufacturing side, and you now are in the manufacturing from a slightly different perspective, but still in the industry.
Yeah. Yeah, it's and to see how INFICON works, or where our background really lies, and why we succeed so much, I would say, on the leak detection side, is because we're a leak detection company through and through. So we actually build benchtop leak detectors for a large manufacturers. Actually, we're the global leader in that.
Hmm.
Um, all the way so we can steal some of that technology and bring it into the field for our service techs to get the same quality and performance that I would say a lot of our manufacturers require. Um, so it's again kind of a soup to nuts or cradle to grave, however you want to say it. But we're able to transition a lot of that technology into a reasonable package for our technicians.
And I doubt everyone realizes that. I've got a link, the one I got on screen. I'll see if I can't paste that as well. So I put the link to take you over to the HVACR section from Inficon. When you get to that page, go back to the home screen and you'll see exactly what Nick is talking about. Is there are a lot of different sections of industries that you actually provide,
Yeah.
refrigerant detection for.
And like I said, anywhere from the HVAC industry to the semiconductor world. So we have a lot of brilliant minds, I would say, at Inficon, and it's been a privilege to work with some of the people here and learn from them, because some of the things we're working on for the future, to what we've been able to come out with, has been really fun and kind of mind blowing. So never stop learning. That's for sure.
No, that's exactly right. So this is actually a segue into a show that we're going to do here in a few weeks where we dive into the different types of refrigerant leak detection sensors that are going to be used in our residential and light commercial industry. But as the prelude up to that, that's where I started learning about all the different sensor technologies. And that's why I think this show particularly is going to be very important for educators as well as technicians to understand that not all detectors are created equal, and really they're very different in the technologies. And so that's what we're going to be doing some deep dives into today to help understand that a little bit.
Yeah, definitely.
Cool.
And there's definitely been some changes in the landscape that I would say have required us to really hone in on our leak detection skills, understand the technology. All leak detectors are not created equal, so it really does make a difference. And again, understanding what it is you're doing is going to play a big part into being successful when it comes to finding leaks.
Yeah, absolutely.
So I do have a few slides that we can go over, and one of the first ones, if you wanted to jump into this now.
Sure.
um, yeah. So why we want to repair leaks, right? We don't want to reduce global warming potential, reduce the ozone depleting potential, but regulatory changes, I would say, are one of the biggest things that have played an impact in trying to reduce some of those things. But it's really changed there's been a shift in the importance and some of the requirements that the techs are responsible for. So what I've seen in a lot of the trainings, and this goes all the way from systems changing gases and people not understanding what leak detectors work with specific gases, all the way to customers demanding reporting, systems, or making sure that leaks are found because they're costly, right? The
Absolutely.
HFC phase down has really increase the cost of these refrigerants. And leak detection from a cost standpoint has never been more important. So there really is, when you're working on systems, there's a highlight on making sure that we can save and do the right things for our customers. So getting ourselves educated on the right tools and the right equipment can help us achieve that goal.
Yep, 100%. We spend a lot of time with our refrigerant manufacturers, our refrigerant reclamation companies, as well as refrigerant management and monitoring softwares. We'll probably have FM Hero on here in a few weeks as well. They were a co-sponsor at the National HVACR Education Conference this year, and they are really helping companies understand those responsibilities of refrigerant management. Because there's a lot of rules and regulations that have changed and brought those limits down into a lot more technicians than used to consider this as a responsibility of theirs.
Yeah, and just to kind of expand on this a little bit, and this is specific for New York State, but I wanted to just show this as an example of what and where legislation might be going towards. The dates on this may not be so accurate anymore, and again, between different regulatory bodies, a lot of this is very fluid at the moment. So, but pay attention to the requirements part of this, and beginning monthly leak inspections, installing automated leak detection systems, requiring and following up on leak repairs, submitting annual reports, maintaining records. These are all things that we didn't really have to deal with before. So when and this is specific to more of a higher end refrigeration big system, but also some of these automatic leak detection monitors are making their way into residential systems, right? They're making their way into like commercial systems. And to understand how that technology is working, if you're getting hit on an alarm somewhere, is it truly going off because that system is leaking, or is it something in the environment that may have caused this to go off? So
Sure.
there are different types of technologies out there, and they do react to different chemicals in different ways. So yeah, that's I think, again, getting familiar and understanding yourself with these technologies is going to go a long way.
Yeah, I absolutely agree.
And so, kind of diving into more of the refrigerant sensor types. Well, actually, let's talk about some of the older leak detection methods that we used to use. So this halide torch.
There we go.
This is what you're looking for.
Absolutely. I've got one somewhere. I just not exactly sure where I've tucked that thing.
Right. And so this was a very I would say it was a good technology for its day. It
Yeah.
told you that there was a gas present, and it was a little bit selective on what kind of gas was there, right? When we talk about chlorinated gases and how that reacted, that's why this works so well. But to bring it into a modern day and try and use something like this is not going to be that effective. It's really not that sensitive when you're trying to chase down small leaks. If there is a fire hazard, right? We're dealing with now A2Ls and A3 refrigerants, so knowing that you can hurt yourself. But for its day, I mean, this was a way to leak check.
Mhm.
The next most common method, I would say, is soap bubbles, right? Everybody kind of uses soap bubbles in different ways. Some people like to go and soak the whole system right when they get there. Some people like to use it as a method of verification. That's really what we say. There is no one method of leak detection that's great for everything. And not one leak detector is going to work for everybody's application, right?
Right. Exactly.
To understand even this as a leak detector, right? If I think I'm going to go and find the small leaks that I'm looking for, understand that a 7 gram per year leak could take up to 15 minutes to make one bubble,
Oh, wow.
right? So if we spray
Wow.
the joint down, or if we spray the connection down, or pipe, and think we're going to see an instant mist, right? Then I may be totally wrong in thinking that I may leave a leak that is there, or even worse, I can mask the leaks because sometimes the leaks are small enough to where it'll plug the hole, so I don't have any of the gas coming out. And so what ends up happening is if I spray the system down with the bubbles. Then I go in with my electronic leak detector. Well, now I've masked that leak. There's no chance of me actually picking up any gas in the air. So the best method to do this is to actually go grab your electronic leak detector, look for the general area, find or pinpoint the leak with an electronic leak detector, and then verify the location. Give yourself a line of sight with the soap bubbles. It's a great way to identify exactly where that leak is coming from, but also to make sure that you're not going to mask any small leaks.
Yeah.
Because if I am getting a hit with a leak detector, but I don't pick it up with the soap, well, you can assume that that's a pretty small bubble. One of the other things that ends up happening with these soap bubbles is when we look at the connections or we look at a flare or something like that,
Yeah, that's what I was
if
just thinking.
if we don't get the soap up into the threads themselves, we actually might miss the leak, because what ends up happening is on the top of the flare, or on the nut part, it'll
Mhm.
actually drip over the threads.
Right, not get
Uh,
inside of it.
so it won't get it up inside there. So
Sure.
I may think that I don't have a leak. This happened the other week. We were leak checking a store in New York City, that they had found with we found the leak with the leak detector. We knew it was there, and it was a big leak. We sprayed it with bubbles, and it was not forming any bubbles. It was completely going over and missing where the gas was exiting from. So it didn't make any bubbles at all. And had we
Wow.
relied on just bubbles, we would have missed a
Would not have
massive
found it
leak.
at all. Yeah.
Yeah.
I think about ductless installations. One of the most common calls that I had when I was in field tech support with ductless systems is poor performance, and it almost always came down to improper installation of line sets with flaring. And a lot of technicians, once they install a ductless system, which is critically charged, will only use soap. And with things like that, a quarter ounce, it's going to take 10 to 15 minutes before you can get one bubble. There's not a technician I know of that's going to stare at every joint for 10 to 15 minutes to see if they get a bubble. So, it just
Right.
goes to show the limitation of using something like a bubble only for a flare connection.
Right. And here's the other thing is, leaks change, right? The properties of the leak and the rate at which a system is leaking changes off the environment, right?
You bet.
The pressure
Changes the
behind the
pressure,
leak
changes the
is
temperature.
what's going to drive my leak rate. And
Right.
so if I check it, let's say on a 20-degree day, or if I'm checking it on a 100-degree day, or if, depending on what that system's doing, let's say I'm going into defrost or something like that, or I just shut down the system and now I'm starting to build up some pressure, that's where I may know I'll have a little more success, right, in finding those leaks. But if I go back to it and try and go over that leak again, this could happen with bubbles. It could be a big leak. I could find it with bubbles today, and then I go back to go find that same leak, or somebody else is going to find that leak, because you told somebody that there was a leak there, and it's not you actually doing the repair. Well, if those conditions aren't the same, and the leak has actually dropped in terms of the leak rate, my chances of actually finding that leak have gone down,
Pretty
especially
slim.
again with something like bubbles, or without using bubbles in the correct way. So I know it seems like a simple topic, and I know that everybody is a fan of bubbles, and I definitely am too. I just think it's good to be aware of what actually is happening. Um, when you are not finding success using bubbles.
Yeah, absolutely. Put some statistics into perspective.
Yep.
Okay.
Another method is dyes. You see this a lot, right? And it's kind of a proven system. It's a good, again, line of sight type of thing. But one method of leak detection isn't great for everything. So this is more of just um, it's more of just an awareness that this is another method to finding leaks. And it's a good way to verify exactly where a leak's coming from, but it's just not very feasible with everybody putting dye in every system. You don't know if it's in there on sometimes. You can, you have to keep buying it. So there are many reasons for it, and there's also many reasons where if you just had yourself a good electronic leak detector that and are familiar with, then you'll have the same success, I would say, or better success than just using dyes themselves. Because I don't always have access to that line of sight, right? It may be leaking from the backside of a pipe. especially in a bigger system. So if I'm trying to shine and look for that leak, if I knew that there was refrigerant present with an electronic leak detector, and then I went to look for that line of sight, it can speed up that entire process.
Sure.
So it cuts down on some of that time.
One of the times where I found that the found that dye was the worst application is I had a commercial grocery store that we had a significant refrigerant leak in the compressor rack room, and after it had lost a significant amount of its charge, for years later, when you walked into the machine room and you turned on your UV light, the entire room was green. So it
Right.
really, once you have a leak with a dye, the downfall is unless it is significantly cleaned, you're never going to be able to, work in that space again because it's all going to be illuminated. So it does. It has some applications, but it can also cause a lot of inconveniences along the way, especially in our larger
Right.
systems.
Right. Right. Another method of leak detection is forming gas, and
Mhm.
most people in the United States haven't really heard of forming gas. And I've talked about this in the past a little bit, but the reason why it's nice to have forming gas is because it's a known mix or known concentration.
Oh, okay.
Um, so what ends up happening is people um, try to make their own version of this by charging with nitrogen and then putting in some sort of refrigerant, right? And the problem with
De
that is
minimis.
de minimis leak, but we're trying to use it as a tracer gas.
Yeah.
Well, the problem is when you have and you're looking for a specific leak, and this is with electronic leak detectors, right? Our leak detectors, the Stratus, is rated down to 1 gram per year. It's the most sensitive leak detector. Actually, this is now the most sensitive leak
Sure.
detector on the
Which
market.
we're going to demo here in a little while, by the way. Make
We
sure you
will,
stay in for that.
yes, we will demo that. But even at a 0.5 gram per year, right? Um, what I'll say is that is a rating that you get off of 100% gas,
Yeah.
right?
Fully charged
So
system.
a full, well,
Fully refrigerant
fully
charged system.
fully refrigerant charge system at 1 gram per year. Exactly. So now if I've charged to, let's say, I've got 90%, like I said, or 95% um, nitrogen in the system, and then only 5% of that is the tracer gas this time. But next time I only have 1% of gas, and I'm looking for that same size hole. Well, I found it on this system, but I didn't find it on that one. And the reason being is because there wasn't really a control method or a controlled tracer gas. So what ends up happening is the dynamics in the systems change, especially on more complex systems with a
Hmm.
lot of piping. There's no guarantee that that gas or that trace amount that you put into it made it in front of that hole to begin
Yeah.
with.
Very true.
And then if it did make it to that hole, I'm not sure what that concentration is. And the key to being good at leak checking with an electronic leak detector, or really anything we do, is to be consistent. And so if I can keep that consistency from one job to the next, in any sort of these leak searches that I'm doing, the chances of me finding these leaks, the rate at which I find these leaks, are going to get better and they're going to get faster.
Mhm.
And I'm not going to miss as many leaks. And it's knowing that is going to make a big difference. One of the other things that you can do, we did a test actually in house here. We pulled a vacuum before we charged with a forming gas. So the forming gas is the 95 nitrogen,
95.
5% hydrogen. So it's a perfectly known blended gas. I know if the gas is in front of the hole, I know the concentration, and the leak detector that I would use is rated for it at a specific rate. So there is no guessing. But even understanding how to apply it right. So if I charge this system, and in this test, what we did was we put the forming gas in without, actually the first step was we put the forming gas in the system without pulling a vacuum on the system. It was actually on a coil, and on the other side of the coil was a 10,000 gram leak, and we had the leak detector up to that 10,000 gram leak. So when we opened the valve to charge the system, we wanted to see how long it would take for us to see that gas all the way through
Makes
the
sense.
coil.
Yeah.
And it actually took about 5 minutes for us to see that
Wow.
coil or that
That
gas.
leak. Yeah.
And so when we also, when we tried it again, but we pulled a vacuum on the system and charged it
Mm,
with the forming gas,
let it
we
draw it in.
we saw it instantaneously.
Yeah,
So
it's a
it
great
was
point.
within seconds. And so just doing something small like that can totally change the outcome, right? That's on a little coil that was, about this big.
Sure.
And it's right in front of us, and we know where the leak is coming from, right? Now imagine you add all of these dynamics to the system, or all of these variables to a system that you're trying to leak check, without a known place or a known source of the leak. So when I'm actually trying to go look for these things, again, the more that I can be consistent on what I'm doing, the more understanding that I have, uh, understanding how the leak detectors work, how they were rated, the gas that I'm looking for. It's going to increase my odds of finding that leak. It's going to make me
Yeah,
consistent.
makes sense. Repetition and
Yep.
consistency.
And so right now we'll get into sensor technologies, but
Okay.
for us, um, the forming gas leak detector that we have, you could use with our gas mate, because it reacts with the sensor that's in the gas mate, but hydrogen doesn't work with infrared cells, so it's kind of out of the band of what we can pick up for an infrared technology.
Okay. Yeah, I've
Um,
actually never thought about using forming gas and a gas detector, but it makes sense.
Yeah, and again, it's as long as you know what leak detectors work with forming gas, you
Yeah,
can't just pick up, like I said, an infrared cell.
you bet.
Really, it's our gas mate, like I said, that will work with that.
Hmm.
Our combustible gas leak detector. Well, then I'll increase I'll increase again the rate that I can find these leaks.
Very
And
cool.
so jumping into kind of the difference in some of these leak detectors, and before we start to talk about the in-depth
Actual
these
technology.
technologies,
Yeah,
this is what you can expect out of some of these, right? And they all have different performance ratings, but in terms of price point, with infrared probably being the most expensive that you're going to find, all the way to a corona suppression, which is an older technology. There's reasons that you would want to use one over the other, and we'll get into those. But if you use each one of these correctly, you should be successful. Some are going to be a little better than others, but you should be successful in finding leaks. Um, so one of the first ones that we'll talk about is ultrasonic.
okay.
And I know this has been a big question for a lot of people as of recently. Um, in finding ultrasonic, or finding leaks with an ultrasonic leak detector. And what's happening is the device, and this is actually ours. This is called the Whisper. Um, so you can kind of see this has a microphone up top. And so this is actually listening to the leak. It's not sensing any of the gas, right? So I'm trying to listen for a specific frequency, that um, the leaks make, and I can translate that into either a beep, or I can actually hear it and translate that sound and amplify that sound.
Sure.
Um, and so where that's good is when we talk about, again, electronic leak detectors, there's specific gases that you have to be looking for, where ultrasonic leak detector, it really doesn't matter. You can actually sense, you can look for a leak in a pressurized leak, or you can actually even look for a vacuum leak. They're going to make the same sound, that this can pick up. So that is one of the methods. The problem is, in terms of sensitivity, I would say you're definitely not going to be as sensitive as, let's say, something like an infrared leak detector, where I'm looking for really small leaks. If I'm getting into that 10-gram leak, 5-gram leak, it's going to be real tough. The other thing with an ultrasonic leak detector is, again, we're looking for specific frequencies. Those holes or those leaks that we have aren't going to be the only things that make those frequencies.
Sure.
So there, it is susceptible, especially if you're talking about noises, mechanical rooms, mechanical components being around there. They can emit this, and kind of imitate a leak. So you may get some false alarms, and there's a pretty big learning curve, I would say, with using these ultrasonic leak detectors.
Yeah,
Um,
absolutely. We think about like what they're looking for. You can imagine, a microphone that is looking for a frequency that the human ear cannot hear on its own. So we're typically in that 40,000 hertz range that we're looking for. So we're talking about a super high frequency. And so we're using a specialized microphone to look for the signature of what that leak could look like. But are there other signatures that could look similar? Absolutely. The nice thing about something like that, though, is it is a universal. We can work with a variety of different refrigerants or chemicals looking for that same signature, but the accuracy, starts diminishing on somewhat.
Right, right, exactly. And so you do have those limitations with that. There are some cool features that it does do, though, and I don't have one here with me, but we have a little emitter that actually emits that frequency,
I've
and it's
seen
a little
that.
black box.
Yeah.
And so what we can do is we can actually do things like check seals. If I'm working in a case, or I need to check if there's any sort of leak of a gasket, I can put that inside the wherever it is, that cabinet, shut the
Hmm.
door, and then I can look around the case or around the door or gasket
Mm,
and
you
see if
bet.
I can hear that sound. So it'll tell me, it'll give off that frequency
It'll
that I
emit
need.
that frequency. Yeah.
It'll emit that frequency, and I can actually tell where, if my gaskets or seals are leaking. So
Yeah,
that's
absolutely.
something kind of interesting that you can do with this that you're not able to really do with other leak detectors.
Yeah, that refrigerant case seal leak, that's a perfect example of, utilizing that technology.
Yeah. And so the next technology that I'll talk about is corona suppression technology, which we don't really have, and it's a little bit of an older technology. So again, this is a high voltage differential between two electrodes, and basically what we're doing is suppressing that corona, the ionized air, I would say, inside of the sensor itself.
Okay, sure.
Um, and so what happens is, as we suppress that, we change the current that goes across that sensor. And so that's the difference that we're looking at. And the problem with this is we end up with a lot of cross sensitivities, and we don't end up with the most sensitive leak detector that we can have. So
Sure.
you can sense many different gases, but I will say, with many different gases that you can sense comes many false alarms.
Right.
Um,
Anything that
so
could get in the air, any
right,
additional contaminants.
right. So you know, and then some of the environments like the dirt, oil, or grease, things like that, are really going to affect the performance of this thing. And also the humidity. So depending on these different environments, it's the environment itself, and the moisture in the air is going to affect how this actually works.
Sure.
Not super common anymore. I don't see a ton of people using this technology anymore. But if it is something that you're using, it's good to understand that you are susceptible to a lot of false alarms, and really be aware of what environment you're working in, what chemicals are around. Is somebody going through? Did somebody just pass through with a cleaner agent for a floor, or a paint of some sort?
Mm.
It really can affect your results with leak checking.
Yeah. I think about all those high humidity environments as well. It's something that's going to throw off that reading.
Yep, yep, exactly. Um, Surface reaction metal oxide, or a CMOS sensor.
Hmm.
This sensor is really absorbing the negatively charged oxygen from the air, so it's more of a reaction type sensor that does heat up pretty hot, several hundred degrees, in order to get that reaction going. Um, the problem with these, again, is you're going to be a little more susceptible to um, cross sensitivities, or different refrigerants, different gases, things like that, to where you can get sensors that are a little more specific and are a little more selective. Um, yeah, so the nice part about these is they do have long sensor lives.
Hmm.
So for ours, we say about 500 hours. To combustible gases, specifically, they're really sensitive. So to those hydrocarbons.
Hydrocarbon. So, okay.
Yep. And so they're not very expensive in terms of a technology. And for us in terms of the tool world, yeah, they have low power consumption, so that way we can extend the battery life for the users. But again, low sensitivity to the HFCs. So again, so some of the refrigerants that we're looking for, it really does. You lose some of the sensitivity that you'd like, but also when we talk about recovery times, reaction times, they are a little slower, I would say, to recover. So when we expose it to a specific gas to get it to clear, it's going to take a little bit. So
Yeah.
if I expose it to a really big leak and then I'm trying to look for a smaller leak, that's when it gets a little bit tricky with these.
Yeah. I think I need to do some comparative analysis on tools that are in the industry because I've been seeing a lot of HVAC refrigeration tools that are being introduced into places like freight tool companies that sell a variety of hand tools. And I'll have technicians go, "Oh, they've got a very inexpensive refrigerant detector." And I go, "Yep." And there's a very good reason why. So
Right.
when we look at that from the perspective of a school, we have schools that are looking for options for the classroom and they're trying to work with their budget, trying to make sure they have enough tools to be able to supply the students. We also want to help them understand, what they're actually getting in that tools. And this is the reason we're doing this show is so that we can understand that the sensors themselves provide a lot of the difference in the capability as well as the pricing in these different tools that are out there. Because there's a lot of them right now.
Right. Right. Yeah. And that's exactly right. I think, again, there's the old expression, you kind of get what you pay for. And
Mhm.
there's a lot of things other than, I would say, just the sensors themselves that go into leak detection, right? Signal processing. So part of it is capturing the signal or emitting the signal. And then the other part is, what do you do with that
Oh,
signal? How
true.
do you make it valuable to the technician to where it's not going to false alarm? You can smooth out some of those background noises. How do you display the actual signal to the tech um, or the user? So, and we've spent a lot of time, and again, we have a lot of engineers here that are really good at what they do. And that's why that Stratus and T-Tech 3 and even the TechMate have been very successful for people, because it goes from just picking the sensor themselves, developing the sensors, to actually using the signals that are coming off of those and displaying them in a way that's going to be valuable to our techs.
Makes sense.
Here's an old trusty
Mm.
for INFICON. So um, this is what's in our TechMate.
Yep, technically.
Um, so the TechMate is a heated diode leak detector.
Very common.
Yep. And so what happens with the heated diode leak detectors are we're heating it up to 760 C, so 1400 degrees Fahrenheit.
Wow.
And what we're trying to do is we're breaking apart the molecules, so leaving positive charge chlorine and fluorine ions. And so we're actually not almost reacting in a way, but changing the signal across the sensor in that way. So it's really sensitive to chlorine and fluorine. And so a lot of like an R22 or a
Mm.
chlorinated gas, that's where you're going to find it be really, really sensitive. And they're not that, because of the way that we're breaking apart and what we're looking for, again, the chlorine and the fluorine. It's not as cross sensitive to, let's say, like the CMOS type sensor.
Sure.
So we can get a little more specific uh, into the refrigerants that we're looking for, and we can kind of um, eliminate some of that background noise that may cause or techs headaches with I think this is a leak, but man, this thing just seems to go off everywhere. So that's where this helps in those instances.
Well, that makes so
Uh,
much sense. When we look at, how things have changed. So I had a TechMate back in those early 2000s. So when I made that transition from 22 to 410A, I noticed that it did not pick up as well. And so that was the transition time that we actually moved away from the TechMates. And now it makes sense is because during that change of refrigerants, the chemical composition was different, especially,
yeah,
when we removed all the chlorinating from that, that would have changed the functionality of the sensor.
exactly.
Cool.
And so Well, and the other part is, again, we're able to become a little more sensitive, so down to a quarter ounce per year, which is pretty sensitive, right?
Hmm.
Um, but I will say what ends up happening with a lot of these technologies, we end up degrading over time. So reactionary type sensors or heated diode,
Sure.
um, a heated diode specifically is going to degrade over time. And one of the expressions that we use is it's like a razor blade. So the more you use it, the duller it's going to get.
Yeah.
And so what ends up happening though is technicians will go out and sometimes I'll ask the question, hey, they'll say, it doesn't seem as sensitive, and I'll ask, when's the last time you've changed your sensor?
Yeah. Not the
And they
tip.
will say,
Not the
yeah,
filter tip, because that's very easy to get confused. I want to make sure everyone understands that there's a very significant difference between the filter tip and the actual sensor itself, especially with
absolutely.
that one.
And so so in the tip here, you'll see that there's a little white filter that should get replaced every so often to make sure that we get the airflow into the unit. But where the sensor actually sits is underneath this cap.
Mm.
And so it's just this little tiny black sensor that comes out. It's got some pins and some leads that you can see there. Um, that plugs right into this socket, and then you can replace the cap of the sensor. But it's really important to change that because again, it's really important to understand how and to be consistent. And one of the good things to do is to really check that your leak detector is working through a calibrated leak. So we sell what's called a tech check, and this is about a 5 gram per year leak. Here, I'll show this right up to the
Mhm.
camera. And so what we do, and the reason why we want to do it is, again, to that earlier statement that these leak detectors, you buy them because they're sensitive to a specific rating, right? And understanding that the heated diodes will degrade over time. What ends up happening for people is they like to check that their leak detectors are working, but the way that they do it, the method that they do it is they put it up to 100% gas, which means they put it
Where's
up to a
where's
refrigerant
the
tank.
where's my hoses on my manifold gauge? There's a de
Exactly.
minimis right there.
Exactly. Well, I even to some guys crack a tank, right?
Yeah.
And they'll
Look in the
some
air.
techs will, yeah, they'll put it right up to the tank, and what you've just done is basically poison that sensor or
Sure.
severely damage that sensor because again, it starts to degrade with the exposure to refrigerant. So
Oh, wow. Yeah.
um, and the thing is, when I'm checking against 100% gas, and I'm checking at a crazy 100,000 gram leak rate,
Yeah.
um, right, that's coming out of that tank when I crack that valve. It's not really telling me anything. And one of the expressions I like to use, it's telling me that my heart's beating, but it's not telling me how much or how well it's beating,
Right.
right? And so what I'm doing with this is I'm actually getting into a range of a specific low level leak. And if I don't alarm to this 5 gram per year leak, I know it's time to change that sensor because that's really the level that I'm trying to get to, or that I expect my leak detector to work at. So if I don't change that sensor and I go through and I do a job, or let's say it's a big store of some sort, or let's say it's a residential system, and I leave that job, and now all of a sudden I get home and I realize that my leak detector wasn't working. Well, now I've got to start that process all
All
over
over.
again.
Wow.
And it's really, really important to just understand what's the health of my sensor, what's the health of my device that I'm using. Um,
Sure.
so to kind of jump into the next technology here is the infrared absorption,
Mhm.
and so infrared is a little bit more of a superior technology. It's very selective in terms of looking for specific refrigerants. And what happens is we're not reacting at all. We're absorbing infrared light, and based off of how much infrared light we absorb, we can tell if there's how much gas is in the air, or if there's gas in the air, depending on what mode you're using, especially with the Stratus. But what ends up happening is we have an infrared source, and that emits that infrared energy. It goes through a filter window, and then there's a detector on the other side of the leak detector
Mm.
that is looking for that signal or that amount of light. And as we look for a leak and we get over a leak, we start to suck in the refrigerant. The refrigerant makes its way into the cell or the tube of um, sensor,
Hmm.
and it absorbs that energy, and it absorbs that light, and so it changes how much light that infrared detector is seeing. And so again, the infrared light is will absorb in a specific wavelength and specific window, we call it. And so anything outside of that window, it's not going to see. It's not going to absorb that infrared light. So refrigerants can be kind of specific, and that's why we have that filter, so we can filter out to a specific wavelength for the refrigerants. Um, the other nice part about this is because it's not reactionary, it doesn't degrade over
Yeah,
time.
sensor life. That
Sensor
makes so
life,
much sense.
well, sensor life is really extended, but not
Yeah,
only is it extended, like uh, let's say our Stratus cell is about 2,000 hours.
yeah.
Um, this has been rated to about 4 or 5,000 hours. I can't remember the exact number off the top of my head. But the important part of that is it is rated to that amount of hours at the same rate as when you first start that leak detector, meaning it does
Okay.
not
No
degrade over time.
deterioration.
Yeah,
Okay. I'm glad you covered this because we're going to spend some time when we dive into the actual refrigerant detection sensors that we're using in our new A2L residential light commercial systems. I'm going to spend a lot of time talking about NDIR, non-dispersive infrared. That is what most, I wouldn't, well, I will say a lot. I can't say most because I don't have a percentage that's actually being used in the industry. But I can tell you from the ones that we're going to be studying, most of those are going to be an NDIR style, which is what gives these sensors such a long life in these residential applications. Many of these sensors, when they're using NDIR technology, are good for 15 years in residential equipment. And now it makes sense because we're not having that reaction on our elements. We're not creating 1400-degree Fahrenheit sensor contact points. So
right.
we're using light and then we're measuring the way that we affect light. So that's a super cool. I may have to borrow that diagram from you or that
Yeah,
picture when we get there.
no problem. No problem. And so for us, this is what ours looks like.
Yeah.
These are sensitive down to 1 gram per year, or tenth of an
Wow.
ounce per year, or better. Again, it eliminates those cross sensitivities. Again, when we talked about quantitative measurements, when we get into the stratus,
Hmm.
we can see that how much ppm is there. It gives you a concentration level, and it also is very, very sensitive to just pinpointing where the leak is coming from. So any gas that's in front of you, we can alert you to that spot, or that pinpointing where that leak is. But we also, in a background environment, can tell you how much gas is present. So
Right.
for like the stratus, that where that's helpful is it can guide me to where that leak is much faster. If I walk into a room, I see one
Sure.
or two ppm. I just keep walking, and as that ppm increases, it's like
Yeah.
a game of hot and cold.
Yeah. You're following concentration.
Exactly. So it's really just a game of Marco Polo with the with the leak. Um,
Nice.
and so with the long sensor life, and a sensor that doesn't degrade, it really becomes a very superior technology, and that's why you see a lot of people moving to it, because it's very reliable. There's a lot you can do with it, and it helps you, going back to that message of staying consistent with what you do. It helps you be consistent, or as consistent as you could possibly be, to make sure you're not missing leaks.
Yeah, and I
Uh,
think about our flammable and mildly flammable refrigerants that we're moving into. Now we've removed that heated contact surface, so that starts opening up a lot of opportunities, I imagine.
yeah, absolutely, absolutely. And so we call this cloud hunting. That's kind of our term. And again, with this infrared sensor, with the Stratus, we can give you that numeric readout. This is what I was talking about with that game of hot and cold.
Yeah,
You can actually display and use the numbers now. Before, with some of the other leak detectors that you'll find, what ends up happening, and people don't
I could
even really understand.
range.
Well, people don't understand that there's an automatic zero function in these leak detectors, right?
Okay,
So when I go over a leak, what ends up happening is my leak detector will alert me, but then it'll auto zero to that concentration. And the reason why we do that
ooh,
is so that way we can alert to the next highest, or get you closer to the leak, so you're not just going off on everything.
Okay.
Otherwise, if I walked into a room and I didn't auto zero, all of a sudden I'll have a bar that just sits up high, or an indication light that just rails without, and I have no more room to go and find where that's coming from.
Yeah.
Um, but what ends up happening though is with refrigerant, it tends to pool, right? And it tends to pool in certain spots. And as it keeps leaking, those little pockets start to grow, and the refrigeration concentration or refrigerant concentration starts to build. And so it's hard to tell. It's not always going to be right at the leak. It's going to be the highest point, or right next to it. It's going to be just a slightly less, and then there, so on and so forth. Little spots are going to end up being a little higher in concentration. So what happens is when we walk in with a leak detector that doesn't show that numeric display, it just starts to rail everywhere, and it becomes pretty challenging to actually pinpoint where that leak's coming from. And so when I can display it in a numeric value, well, now I can start to really gauge just based off of that number. I'm starting to get close to that leak.
Very cool. Yeah. So as you start, moving it into an environment with a known leak, it's kind of like using a metal detector. We're actually honing in on certain areas and then re-zero and pinpointing, but we're doing that with software so that we can get closer and closer and closer to that leak.
Yeah, and
Yeah.
so one of the things in the slides that I like to show is this slide here, and the reason why I like to show this is because it's very similar to a golf swing, right? A little adjustment in what I'm doing, or a little more understanding of something that's happening in that swing, can make a big impact on my success. And so when I walk into any sort of, if I'm going to do any sort of leak checking, it's important to make sure your equipment's working, understand your method that you're doing. So if I'm talking big refrigeration, where am I positioning this leak detector as I'm walking to the source of the leak? If I'm working on a residential system, is the outside, is there wind? Is this a high pressure system, low pressure system? Is there
Yeah.
any gas in the system, right? Am I in pinpoint mode? Do I need to use cloud hunting mode? So having a plan of how you're going to approach this with all of those, scenarios in mind is really going to help elevate your ability to find leaks.
Hmm.
And then keeping good documentation, right? When the last time you checked your sensor, or the last time that you've replaced your sensor, keep good notes. How many leaks have you found on certain systems? Keeping documentation again for more of the bigger refrigeration markets, being able to do that. And also, again, maintenance of your tools themselves, understanding, again, when's the last time I changed a filter, when's the last time I changed a sensor.
Wow.
That's all going to really help us.
So you see the infrared is becoming our primary refrigerant detection sensor going forward.
Yeah, I think this has been, it gives us the ability to be as sensitive as we possibly can be, the most selective, I should say, with the least amount of cross sensitivities, and the most consistency. So if you're looking for, it doesn't have to be right a Stratus, but we do have something for us, and I don't have it with me, but is the Detect-3, which is kind of the little brother to this unit, and it just
Sure.
doesn't have a screen. But the core technology is still there, and it still uses these sensors. The other thing we're able to do with infrared is we can start to swap out which refrigerants, and I'll go back to this slide here so that way we can see what I'm talking about. But all we have to do with this guy is pull this battery door off and pull out this this sensor, or the cell, people like to call it. And we can swap this out with a different sensor. So for us, they're color coded. And
For the
this is
types of refrigerants.
for the types of refrigerants. So this is actually a CO2
Oh,
sensor. So I can actually totally change what type of leak detector I have. So I went from a refrigerant sensor to a CO2 sensor, and we also have a hydrocarbon sensor.
really? Okay, so we can here's our unicorn.
Right.
If
So it's
we're looking
really
for that unicorn tool, it's this one with the different cartridges for whatever refrigerant we could be potentially working with.
right. And so it allows us to do that, to be really sensitive, to swap
Huh.
out those. And again, same thing. It's going to give you the numeric displays with those different sensors. if you want that, or you just get that consistency, that sensitivity with the Detect-3, with the ability to swap out to different cells.
Sure.
So that's really been a game changer, I would say, in terms of what people are looking for, where they're finding success. Infrared technology has really changed the
Oh, it's
game
a
for a
game
lot of
changer. I've got
technicians.
to upgrade. I'm still a heated diode. And so
Yeah,
I can see, yeah, infrared is going to be the way I'll want to look because, going forward, we're going to be doing, classes and we're going to be in installations and, working with different manufacturers. And so if I'm going to be using, and traveling with one refrigerant detector, if I could do something that I can work with my HFC and HFC blended refrigerants with one, I can swap it out, do my hydrocarbons with another or CO2 and still keep the common detector.
right.
That's a pretty significant savings in the long term. Now, I'm sure there are going to be, technicians in schools that will only be working with one. You may never have hydrocarbons in your classroom or CO2. So, we have other applications, but when we look at the ability of infrared, it really changes the game for all technicians and educators.
Right, right, exactly. And I think it's again, it comes down to, not that heated diode is bad. Like I said, it's
Yeah.
just it takes a little more to understanding of what's going on in that environment. It takes a little more understanding that they have the upkeep. You have to remember, that you have an issue. The nice part about more modern tools or some of the newer technologies is when this sensor fails, it's going to indicate that it has a problem, right? Versus our older tech mate, where it's not really going to be able to do that because it degrades over time, and
Yeah.
I don't really know where the health of my leak detector is.
Yeah. You
is
don't have a
so
baseline.
I'm actually going to start this up just to show you guys.
Yeah,
Maybe
absolutely. We got 4 or 5 minutes left. This would be a great time to, demonstrate how we're actually testing using a known refrigerant. And so
right.
another thing I definitely encourage everyone to take a look at, especially in our classrooms, so we have comparisons, especially for our students, is to make sure that we have a common refrigerant leak to measure
And
against.
and so I'm going to demonstrate this with the Stratus just because it has the screen and it's the easiest to see.
Yeah.
But with this leak detector, as I think you might want to.
Yeah, I was trying to move this and give you full screen, but it's not letting me do it. So I'll just go down here
Yeah.
and I'll be the small
Here,
for right now.
how about this? I will take off
No, you're good
this
there.
pop. Here we go. So yeah, so as I pull this out, the sensor out, get it out. There you go.
Oh,
So
sure.
now I have a sensor fault, and so now I know I'm not going to run around with a leak detector that isn't working or isn't as sensitive as it should be. So I know exactly what's happening with my tool. It's going to give me those indications. It's not a guessing game
Yeah.
to how well this is performing. And again, like we said, with infrared technology, it's as good from when you start that device to when that you get that little message that it's time to change the sensor. The next thing that I wanted to talk about is, and what's happening is, we're starting to get and understand how important airflow is
Mm.
in these leak detectors. So, before, like, let's say even something like our gas main, where it doesn't have the ability to bring in the sample, or to bring in the refrigerant. You're going to have a tougher time on trying to find those leaks. And there really is, um, you know, been a big improvement with the amount of airflow that we have in some of our newer leak detectors. And here's a little demonstration that I like to do, between our newest one that we just came out with and even the Stratus. And I can do this because they both have screens, so we can show you.
Hmm.
We can actually show the difference in airflow and how much that makes a difference in leak checking. So if I put this Stratus right on top of this leak, and again, this is about 5 grams per year. Um, this Stratus is pretty good with airflow. This unit has about 10 times the airflow. And so what ends up happening is, just to show you how this will transfer, um, I'm going to put this probe right next to this other unit, uh, and you can see the leak transfer from one leak detector to the other. So it actually makes its way to the other
The one with the
screen.
better pump.
And when I go back and and take that away, you can see the leak go back into the leak detector, or the Stratus leak detector. That just shows you how much airflow, and we're not talking, like vacuum cleaners here.
Right.
We're talking just a little bit of airflow. And that can make the biggest difference in the world. So having a pump that can bring that into the leak detector, and let's say I'm on the backside of a coil or something like that, this has been a pretty, I'm going to say this has been a pretty good leak detector for us, and many people like it. And you can see that it does pick this up. But I kind of have to be right on top of the leak in order to pick this small of a leak up. Again, 5 grams per year. So again, what airflow can do for us, showing you this new one, is I can be pretty far away, about an inch away or more, and I can still pick up that leak. Detection. And so if I apply that to in the field, if I'm an inch away, or if I'm 2 inches away, or a foot away from a leak, depending on the size of it, if I don't have airflow, I can actually miss that leak because I'm not close enough to that leak. So having a leak detector that has good airflow is really important to being able to find the source, or pinpointing that leak.
No, absolutely. Completely makes sense. Well, Nick, this is fantastic education. We went through every generation of leak detector, from our halide all the way now into our infrared. You've done an amazing job explaining it. Does anyone have any questions in the audience? I hope this really clarifies it, because even myself, I was a little confused. I wasn't necessarily confused, just not as well educated on how the technologies are working better. I knew that the infrared was really moving into the industry, but I didn't know exactly why. And so you've done a fantastic job explaining that. And for those that want to learn more, I don't know if I still have, do we still have that one slide up with contact information, Nick? In case anyone wants to get a hold of INFICON, I encourage everyone to reach out to INFICON, learn a little bit more about what they're doing in the industry. We actually have a partner page as well. Let me grab that partner page and throw that up. We actually have partner page on the HVACR Learning Network that will get you over to some of our INFICON resources. And I will throw up some contact information for everyone as well. All right, and that about gets us to the end of the hour. No questions out there. I'm surprised we don't have anybody that wants to have some extra questions or comments on this. I appreciate everyone joining us. It is Andy. Thanks for joining us. I know this really helps us understand what's going on. We try to bring all of the most current information to the industry. We always say that, you go to one conference in our industry to see what's coming out for the year. You come to our conference to be able to learn how to work on that and how to teach it in the classroom. And then you come onto the show and we can continue that education to be able to spread the word on what's changing in our industry so that we have a better understanding. Most of us educators came from the field. We knew what we were exposed to very well. But as technology and innovations change, we have to stay up to date with that. And that's really our goal and our mission here at ESCO and the Did You Know show. Well, Nick, we sure thank you for your time. I appreciate all this
pleasure being here.
Yeah, this is fun. This is, it's the details that we all need to know that we don't always get.
Yeah, and leak detection isn't always the most fun part of the technician's job, right? It tends to be something that is more tedious. So whatever you can do to kind of speed up and make that process a little easier, I find that people enjoy that, because again, it's just such a tedious part of the job.
I agree. And understanding the capabilities. You've been using it for the last 10 years, it's probably not working very well. It's time to start looking for some additional ones, even in the classrooms. And so we provide you these resources to stay up to date.
I think Andy asked when the Pro version is going to be available. We're targeting this summer for it to be available.
Excellent. All right. Well, I encourage everyone to reach out to INFICON, dive a little bit deeper into their products, and we will see you all again next week on Did You Know, the ESCO HVAC show. Thank you all for joining us today.
Bye. Thank you.